Okay, so this is the last talk of this session, and it's by Stratio, and it's going to be tag teamed by two people. The talk is given by Luca Rosellini and Alvaro Agea.
Yeah.
Correct. And they'll be talking about their integration work of Cassandra and Spark. So please.
Hi, everybody. My name is Alvaro.
And I'm Luca.
We are big data architects in Stratio. Stratio is a new Spanish startup that works only on big data projects. We started with this summer, and now we are developing different products and technologies for this type of problem. It is evident. We love Cassandra, and we are creating a new platform around this technology. In this slide, you can see the main components in this platform. StratioDeep for the analytic search, Stratio real-time for the stream processing, Stratio Meta for the language, and Stratio Boost. Stratio Boost is a communication framework. It's the glue in the platform. With these tools, we have a complete big data platform. We want to create a new database as powerful as Cassandra and easy as MongoDB. Part of this solution is ready and is integrated in production environments. We are already working to improve these tools and search for new features for the Cassandra developer. This is one of the main challenges for Stratio. We want to help you while powerful and efficient solution using this technology. Our platform has different components, but in this presentation, we're going to focus in StratioDeep. Because StratioDeep is a cornerstone in this platform. All databases need a tool to search information in depth. StratioDeep is an integration between Cassandra and Spark. With this integration, we are able to resolve new problems that are impossible to resolve only with Cassandra. We believe that Cassandra and Spark are good friends because Spark allows Cassandra to make impossible searches, and Cassandra can use the index to optimize the Spark map process. Okay, so everybody knows Cassandra, but maybe some people don't know why you must use Cassandra and what problems you can find if you don't design the schema correctly. But right now, we are going to explain why Cassandra is important and what use cases are perfect for Cassandra. With our experience in big data project, we have been able to identify the 3 most typical use cases in this type of projects. The first case is the most traditional. When someone explains what is the big data problem you've seen in this case. One person searches through a lot of data. This case is used when an analyst wants to access a big data repository. You need to distribute the information because it's too big. But the search process is very hard, and the cluster can support many concurrent searches. The main solution for this case is to use tools based on Hadoop, like Cloudera, Mapper, or Hortonworks. The second one is a case that many people think is not big data. You really don't have a lot of data, but you have many users search information. The key, in this case, is replicate information. It's the case, and you also need a log system that allows you to date the change in all nodes at the same times. This case is perfect for other databases, such as MongoDB, MySQL, MariaDB, PostgreSQL. And the last one is a hybrid between the first one and the second one. It's also the most complete, because you have many users and a lot of data. In this case, you must design the queries correctly, because you need a database that is prepared for specific searches. This is the perfect case for Cassandra. This is case a common a lot of samples, machine-to-machine communication, financial transfers, mobile apps, load monitoring, and surveillance systems. And the last one, Cassandra isn't designed to resolve all searches. You need to design the database schema thinking in the query, but you are often going to need other queries. And you can change the schema for a particular requirement, in this case. In this case, you need a new piece can search through your database without restriction. In the traditional database, if you haven't got an index, you must use the full scan search. This is a similar situation. Spark resolves this problem. Spark is the full scan search. And this is the main reason we created the StratioDeep. With this technology, you can resolve your data, you can explore your data without limits. And now, Luca, my colleague Luca, is going to explain how we have integrated this technology and the main feature of StratioDeep.
So, in this slide, I think that's something wrong here. So, okay, from Spark point of view, integrating with Cassandra is as easy as developing another RDD. An RDD, inside an RDD, the main abstraction is everything revolves around the concept of a partition. So what we do here in our architecture is to map Spark partition to Cassandra token ranges, and as you can see in this picture. And beside that, we also provide a function in order to compute the Spark partition over the Cassandra token ranges. Moreover, in Cassandra, each token range, which is also called split, is replicated across the cluster. So what we do is to provide Spark with the location of each replica in the cluster, and let Spark decide which replica to use in order to perform the actual computation. Which features do we provide? Well, we are fully CQL3 compatible. So this is mainly because we are using, in order to develop the integration, we are using the CQL paging input format, which is an object provided by Cassandra, which is inside the Hadoop Cassandra interface, and which is the main hook that we use in order to develop this integration. And most important, and that's something that really that's really our greatest advantage over, for example, Spark over HDFS, is that we can leverage the power of Cassandra secondary indexes in order to efficiently fetch data from the data store. And this is so important for us that we are actually developing a custom implementation of Cassandra secondary indexes in order to make this integration and the fetching of data even more efficient. So, and beside that, our implementation is quite small. The code base is quite small, so we think that we got a very simple and elegant solution. So, which other features do we provide? Well, we are really we are really friendly to Java developers. Well, you maybe can't believe that, but in Europe, the diffusion, it is quite difficult to convince our customers to use Scala. Well, they still don't trust us. So we focused on Java developers, and we provided a really Java-friendly API. So developers can use StratioDeep and build a Spark RDD, providing a custom POJO that maps the schema of the Cassandra column family that the RDD is representing. So under the hood, what we do is to transparently do the computation over the user-provided POJO. So there is no need for developers to perform ugly manual conversion between Cassandra byte buffers and Java types. So I think it is really unique in StratioDeep. And most important, we are developing right now an high-level SQL-like language. So maybe many of you right now are thinking about Shark. We are quite different from Shark in the sense that well, we are based on Spark API. We will provide a SQL language. In the future, we will also provide a LINQ abstraction, because over there are many customers that are using LINQ. And what it really, this language is so important to us that what we are doing is using this language as the main interface through which our customers can access all of our platform modules. So, for example, our customers can maybe access Stratio real-time features using our language, and the queries developed with our language will be translated to Spark streaming APIs. Or maybe they could command the Stratio bus. And as Alvaro said, Stratio bus is the main glue between the modules of our platform, and its main abstractions are channels, consumers, and producers. And what we provide is, furthermore, that we want to be able to create data flows between a StratioDeep and a Stratio real-time, and vice versa. So if you got the ability to create data flows, you can maybe, for example, using StratioDeep, create materialized views inside the data store, and later keep updating them, the data inside these materialized views, using Stratio real-time jobs. So we will have a language. Our language will describe the queries that will be performed inside the platform. The language will be processed by the component called StratioMeta, and StratioMeta will launch queries on both StratioDeep and Stratio real-time, and will configure the Stratio bus in order to connect the data flow between the two. And well, a data flow could also be a data flow could be a flow of data coming from the outside through the Stratio bus. So we will keep using our DSL also to cover this case. And well, once the data come from the outside through inside the platform through the Stratio bus, we will process them maybe with Stratio real-time. And here the basic idea is that we will have one language in order to command all the modules of the platform. So with StratioDeep, what we are doing is covering an even more complete use case. So we are covering a use case which is an hybrid between use case A and use case C, in which not only we got a lot of users and a lot of data, but we also have a few data analysts that with a powerful tool in their hands in order to perform queries. So well, we know this is an ambition project. Some components are already being developed. Some of them are in production. For example, StratioDeep is right now in production. But we think that in the end, we will have a really complete and easy to use big data platform. And I think that's all. Thank you.
Okay. Any last questions for today? No questions? Okay, I have a question. So, so did you try using Shark, or?
Yeah, we use Shark, and well, the customers of us needed quickly the features provided by Shark, so we had to we install in their production system. But what we did is that we had the customers with a lot of data in a Cassandra cluster, so we really thought that we had an opportunity to integrate Spark with Cassandra and provide our customers a way to do analytics against this data without having to fetch data from the Cassandra data store. So that's the main reason why we started this integration. And later, what we did was thinking about a more general platform, and that is where we are right now.
Okay, thank you. Let's thank the speakers last time.